Hello, welcome back to the channel of Commonomics, a platform that exclusively discusses economics and econometrics. Today, what I am going to show you how we can do the regression analysis using Excel manually, that means without using any data analysis toolpack. How we can derive the OLS or regression coefficients, then how we can find out the standard error variances, then t-value, the probability values, confidence interval, and all such things. That means all estimation methods and evaluation methods associated with a two variable or simple regression model. Okay, so assume that we have a two variable y and x. As you know that uh, this y is a function of x. Y is a function of x. Okay, so here we are having the total number of observation is equal to uh, count. Click it here. Yes, we have total observation is 10, and our equation is y is a function of x, y is the dependent variable, and x is the independent variable. Okay, yes. So this can be the regression is assumed that regression equation is linear in parameter. Okay, so this functional form we can convert into a linear equation, just like y is equal to b0 plus b1 x. Okay, yes. So in econometrics, so this is just a functional form. This is linear form. Okay, then if we add a term y is equal to beta 0 plus beta 1 x plus u, okay, then this is known as stochastic specification of linear regression model. Okay, so our regression model is just like this. It shows that y is depends on x and some other values. Okay, the error term will capture all other omitted variable or omitted values or omitted variables from the model. Okay, that will influence y, but we are not including in our model explicitly. Okay, yes. So in regression, what's our aim? Aim of the regression is find out the value for beta 0 and beta 1. Okay, look at the values, look at the variable parameter I have written, capital beta 0 and capital beta 1. Okay, so why I am putting beta 0 means it indicates population. Okay, so assume that there are 1,000 populations. Okay, 1,000 members are there in the populations. Okay, so from 1,000 members, okay, if we find out the value for beta parameters, okay, so that is beta 0 and beta 1, it will be our population parameter. Okay, but we have only 10 sample values taken from these 1,000 values. Okay, so what we have to do, we don't have information about these things, but we are only able to calculate small beta 0 and small beta 1, and this small beta 1 is beta 0 and beta 1 are sample statistic. Okay, yes. So our aim is what? Estimate beta 0 and beta 1 on the basis of beta 0 and beta 1. Our aim is to find out this value. Okay, but we are not able to do that because we don't have that much data. We are having only 10 observations, so we can only estimate this small beta 0 and small beta 1. Okay, so we estimate the small beta 0 and small beta 1, and on the basis of the small beta 0 and small beta 1, we will infer what is this capital beta 0 and capital, or what is the parameter on the basis of what is statistic. Okay, on the basis of statistic, we are inferring what is the parameter. Is it okay? So that is the aim of the regression. Okay, so when we do that, okay, so what we do is there will be changes in y. Okay, then changes in x is also there. You look at this data, y is changing for y values are different for different individuals. Okay, this is also different for different. Okay, you assume that y is the consumption and x is the income. Okay, yes, so consumption depends on income. Okay, so what's our aim of the regression? We have to find out changes in consumption, okay, and you look at there's a changes in income is also there. Okay, okay, so our aim is what? We have to estimate the changes in consumption when there is a changes in income. That means when there is a changes in income, how much percentage changes will be there in the consumptions. So that is the major aim of the finding the regressions. Okay, so how we can find out the changes in consumption due to changes in income? It's nothing but the slope values. Okay, so in this model, if you look at this model, there are two parameter. One is intercept, it is beta 0, and one is slope value, it is beta 1. Okay, this slope beta 1 or slope coefficient beta 1 tell us changes in consumption due to changes in income. Okay, or changes in y due to changes in x. Okay, then what is beta 0 will give us? It will tell us what will be the value of y when x is equal to 0. What will be the value of y when x is equal to 0? Okay, so this is what is the major aim of the regression analysis. Okay, yes, so finding out this beta 0 and beta 1 is the major role of the regression in statistical estimation or econometric estimations. Okay, but we have to find out, so when we will get a better value for beta 0 and beta 1, when we will get a better value for beta 0 and beta 1, we will get a better value for beta 0 and beta 1 when the effect of all other terms is minimum. Okay, so that means in this equation we are having a deterministic term and stochastic term. Beta 0 plus beta 1 x is the deterministic part. Okay, then u is the stochastic part. Okay, so we can able to explain the changes in y using changes in x only when our error term is minimum. Okay, so our main idea is to convert, or what we have to say, main aim of the regression is to reduce, to find out the value for beta 0 beta 1 by minimizing the error. Okay, yes, So how we can find out the value for this? Okay, so let me check you how we can find out the value for, yes. Okay, so first thing what we have to do is we have to find out the value for beta 0 and beta 1. Okay, so what is the equation for that? Beta 0 is equal to sigma, I am putting E for sigma, sigma xy divided by sigma x square. Okay, so what is beta 1? Beta 1 is y bar minus beta cap 1. Okay, beta cap 1 means estimated value of beta 1. Y bar minus beta cap 1 into x bar. So finding out this value is the major role of the regressionist. Okay, how we can find out that, we have to check. Okay, so you have to understand this. In this equation, we are just in this first equation, slope equation, we are just putting small x and small y. Okay, so small x is equal to what? X minus x bar. Then small y is equal to what? Y minus y bar. Okay, yes. So how we can find out it? Yes, for that what you have to do is you have to find out the average first. Okay, so find out the average of y is 115. Okay, you put the cursor here and just drag to here, then you will get the x, or average value of x. Okay, we have got 115 and we have got, yes, 170. Okay, now what you have to do is you find out small y and small x. You find small y and small x. Okay, how we can find out small y? This 55 minus this 115. Okay, so you do that one, you get minus 60. Okay, then if you drag it, you won't get the values, you will get the errors, because we are no, the same value is repeating here. So why it has happened, so this is the mistakes, I'm just undoing it. The thing is that these y values are changing, but the x bar is x bar is not changing, it is constant. Okay, so whenever you put a constant value in Excel, you have to tell to Excel that this value is constant. So I am just, for that what we have to do is we have to put a dollar symbol. Okay, so dollar symbol means that this value is a constant value. Then you just click it, now you drag it, then you will get these values. Okay, yes. Now after that you just drag to this area, then you will get the x values also. Okay, no need to do the, no need to repeat the same things again, you can just drag to the right side, then you will get the small x also. Okay, then if you find out the sum of these things, you will get 0 always, because it is due to the first properties of the arithmetic mean. That means sigma x minus x bar is always is equal to 0. Okay, yes. Then what we have to do is you have to find out the y into x. Okay, for that what we have to do is this is y multiply with this x. Okay, yes, we have got y into x. Then what's next? Yes, x square, small x square, this is the small x. That means in regression equation we are squaring the deviation of the independent variable, not the dependent variable. Okay, so the denominator is always an independent variable. Okay, so this is just square it, For squaring, you can put the cap symbol, okay, which is there on the number 6. Okay, you square it, you got these values. You will get these values. Okay, yes. Then what you have to do is you have to sum these values and you sum these values also. Okay, now you got the equations. Okay, so this is what is equal to, this is sigma x into y means 80,920 divided by this 33,000, 0.7333 something like that. Okay, then next is what we can find out the beta 1. Sorry, this is beta, yeah, so this is beta 1 and this is beta 0. Okay, yes. So this is 0.573, and you have to remember that first we will get the slope parameters. If you got the slope parameters, then only you will get the index of parameters. Okay, so this is equal to y bar. What is the y bar? 115 is the y bar minus this is your estimated beta cap 1 value or beta 1 value into your x bar. Okay, we have got 17.533. Okay, so we have estimated the value for beta 0 and beta 1. Okay, so this is what we call the regression analysis. Okay, yes, then how we can interpret this? It tells us that, okay, whenever your income increase by 1 unit, income is always measured in terms of rupee or dollar. Okay, so whenever your income increases by $1, your consumption will be increased by $0.57. Okay, then if there is no income for a person, then he has to get at least $70.5 to spend for his necessary purposes. Okay, so this is the way we can find out the oilless estimators. Is it okay? Yes. Now, uh, let me calculate the y cap for all pupils or all observation. What is y cap? Y cap is nothing but the estimated equation for a particular observation. Okay, that means look at the equations. Okay, we have got alpha beta 0 plus beta 1 into this particular x corresponding to the 55. Okay, so the 63, and you have to remember that this beta 0 and this is beta 1 are constant. Okay, so you have to put the dollar symbol, then only if you drag this value you will get the values, correct values. Okay, so we have got y cap. What does it means? It means that for this fellow 55, his income was 55. Okay, so his consumption was 55, but when we estimate the regression model we have got 63. When we estimate the model we have got 53, but his actual consumption was 55. Okay, but you have to remember that in regression model we are always measuring the average consumptions for a group of people. Okay, so we will not consider the individual uh, estimates. Okay, so his consumption is 55, but when we estimate this model, that means when we uh, substitute the betas b0 and b1 in equation, okay, and by multiplying with independent variable we have got a value, that value is known as estimated y. Okay, so this is our actual y and this is our estimated y. Is it okay? Yes. Now this is y cap and this is y and this is y cap. Okay, but you can see that y and y cap we can see the differences. Okay, So the difference between y and y cap is known as u cap. Okay. So difference between y and y cap is known as the errors. Okay. So in first case, what is the error? Okay. This is the actual value, but we have estimated, or we have overestimated. So there is a mistake. There is an error of minus 8.4. You drag it for all. Okay. So we have got positive errors and negative errors. Okay. So this is what we call positive errors and negative errors. Okay. But if you sum this error, you will always get 0. Okay. So in Excel, if there's a if you after the calculation, if the value or if the letter is coming, then it means that it is 0.0000 something. Okay. So how we will get this value, exact value? You click this value, then you just format this values or format this column or format the cell with number. Okay, then you will get 0. Okay, so if there is 0, if there is e appearing, then you have to understand that it is 0.0000 something like that. Okay, and how we can convert into actual values? Okay, you right click, okay, format the cell for number, then you will get the value. Okay, so we have got u. Okay, so here you have to understand one thing. Okay, so in our main idea was to reduce the errors. Okay, but if you take any values for this y and x, okay, this error sum or sum of the errors will be always equal to 0, because okay, because of this property, because of the first property of the arithmetic mean. There will be positive values and there will be negative values. Positive values will be exactly balanced or offset by the negative values. So sum will be always equal to 0. Okay. So in regression model, our aim is to reduce the errors. Okay. But when we adopt a criteria of sigma u or sum of the errors, that will be always equal to 0. So what we have to do? So we cannot adopt this criteria. Okay, so in order to overcome this criteria, we have to adopt another criteria called the sigma u cap square. Okay, so in order to overcome this issue with the sum is 0, what we have to do is you multiply this you square this u cap. Okay, you just square it. Minus 8.4 square is 70.56. Okay, then you do for all. Okay, then you submit. Yes, we have got 1046. 1046. Okay, so what does it mean? 1046. It means that the squared errors, the sum of the squared error is 10.46. Okay, and our in regression model, our aim is to reduce the squared error terms, or this is what we call the RSS, residual sum square. Residual sum square. Okay, then this residual sum square will be always minimum. Okay, this RSS is always minimum when we do the OLS. Okay, so that's the advantages of this OLS. That means there are there are different assumptions for OLS. If the assumptions are true, then this RSS will be minimum. That is one of the main advantages of this OLS method. Okay, yes. Now what I'm going to tell you is, now we have completed the analysis, or we have completed the regression models. Okay, we have find out this beta 0, beta 1 values, and we have find out the RSS. Okay, now what we have to do is we have to find out the R square. Okay, so R square is means nothing but goodness of fit of the model. That means how much percentage of the variations in Y are explained by this X. Okay, so it is there are for a y is a function of X and U. Okay, that means Y is equal to X plus U. Okay, that means there are deterministic part and stochastic part. Okay, so how much variations in X in Y are explained by X, and how many variations in Y are not explained by this X, that we have to find out. Okay, yes, that means if almost all the variations in Y are explained by X, then the goodness of fit of the model is good. Okay, or if the variations in Y are not explained by X, then it means that other variable or other variables that are not included in the model are explained in the variations in Y more. Okay, yes, so how we can find out that? For that, there is an equation is that ESS divided by TSS. Okay, or 1 minus RSS divided by TSS. Okay, both are the same. R square, this is also R square. 1 minus RSS divided by TSS. Okay, RSS we have found. Okay, then what is this ESS? ESS means estimated sum square. Estimated sum square. Okay, that means it is sigma y minus it is mean by sigma y minus sigma y cap minus y bar square. Okay, then what is TSS? TSS equal to sigma y minus y bar square. Okay, so let me find out the ESS first, or let me find out the TSS first. Okay, so this is the small y. Okay, that means small y means what? Sigma y minus y bar. Okay, so you just square it. This is y square. You do it for all. Okay, then you submit. Yes, you have got 11,8994. Okay, so this is your TSS, total sum of squares, or total deviation, or deviation in dependent variable from its average. Okay, yes, then this is y, yeah, this is y square. Okay, now y cap square, small y cap square. Okay, not capital Y cap square, small y cap square. Okay, so this is our y cap. Okay, so before that, let me tell you one more thing. If you find out the average of the y cap, okay, that will be equal to this. Y bar and y cap bar will be always one and the same. Okay, so what we have to do, you can take y cap, this is y cap minus y bar or y cap bar. Okay, then you square it. Then do it for all. Then you submit. Then we have got 1000. Yeah, 1000. Sorry, 10,847 is equal to 1,847. Okay, then what's RSS? I have told you this ESS divided by TSS. Okay, how much? 0.9120. Then what does it mean? It tells that 91% of the variations in Y are explained by the X, and almost 9% of the variations in X are not explained by this X, and it is explained by some other factor. There are some other factors that are explaining 9% of the variations in Y. Okay, then you can alternatively you can use the other equations. What is that? 1 minus RSS, this is RSS divided by TSS. Okay, so both will give you the one and the same answer. Okay, so this is the way how we can find out the goodness of fit of the model. Is it okay? Yes. Now what we have to do is, after finding out these things, next idea is we have to find out the variance. Okay, variance of beta 0 and variance of beta 1. Why we need to find out the variance? Because variance will measure how much variations will be there in these parameters when you change the sample. Okay, so we had a sample of 10,000, so we had a population of 10,000. From 10,000 we have taken only 10 samples. Okay, then we have got 0.573 and 17.53. If you take some other 10 samples, other sample with 10 observation, you may get some other value for beta 0 and beta 1. Okay, then if you take another one, you will get some other values. Okay, but our assumption is that the variances among these estimators should be minimum as possible. The variance should be minimum as possible. Okay, so how we can find out this variance of beta 0 and beta 1? It is very simple. Okay, so for that what we have to do is we have to find out there's an equation is uh, this is the equation for that, small sigma divided by sigma small x square. Okay, so this is not very this is for this. Okay, beta 1. Okay, then alternatively for this there is a and one more term, it is standard error of beta 1. This is nothing but the this divided by small sigma divided by then yes root of small sigma divided by root of sigma xi square. Okay, so variance and standard error both are the same things. Okay, so variance root of the variance is standard error. Okay, so alternatively we use variance and standard error. In some econometric package they are giving standard error, or in some package they are giving variances, in some package they are giving both variance and standard error. Okay, so whatever may be the variance and standard error, it both will conveying the same idea. That means measuring the standard, measuring the variations or measuring the accuracy of the estimator or measuring the reliability of an estimate. Okay, then similarly we can find out the variance of beta 0 and standard error of beta 0. How we can find out variance of beta 0? This is there's a some big yeah, standard deviation square, okay, into sigma capital X square divided by, okay, n into sigma small x square. Okay, then if you find out the root of this beta 0, then you will get variance of beta 0, you will get the standard error. Okay, then what is this value? What is this value? Small sigma, it is nothing but the standard error of the regression model. Okay, so it is nothing but RSS divided by n minus 2. What is n minus 2 here? N is total number of observation, 2 means total number of variables. So we are having only 2 variables, so it is RSS divided by n minus 2 and it should be under root. Okay, yes, should be under root of RSS divided by n minus 2. Okay, so we can find out this value. Okay, we can find out this value. First we have to find out this value. Okay, how we can find out? Square root of SQRT, square root of RSS, this is the RSS, okay, divided by 8, 11.43. What is standard error? 11.43. Okay, yes. Now we can find out these values. Okay, first variance of the beta 0, beta 1. This is the small sigma divided by sigma small x square. Okay, this is the small x, then this is the small x square. 0.000347. Okay, then what is standard error? This divided by square root of SQRT of variance or SQRT of sigma xi square is 0.062961. Okay, so this is the way how we can find out the variance of beta 1 and standard error of the beta 1s. Okay, then for finding out this variance of beta 0, we have to find out capital X square that we have not found so far. Okay, so this is the capital X, you square it 6400, then you do it for all, then you sum it. Okay, yes, now we have got it. Okay, so we can do, yes, standard small sigma square, okay, into sigma x square, capital square, so this is the sigma. Okay, there's a mistake, wait, yes, it's equal to this square 130. Okay, so 130 into sigma x square. Okay, so very big values. Okay, no problem. Then you find out n into, n means 10, 10 into sigma xi square, 30,000, 33,000. Okay, we have got 33,000 something like that. Now we can find out Okay, so this is equal to this divided by this. Okay, how much we have got? It is 127.6454. Okay, then what is the, if you find out the square root of this, 11.2980. Okay, so 11.29802. So this is the way how we can find out the variance and standard error of the regression model. Okay, so far we have checked goodness of it and precision or accuracy of the statistical test, or accuracy of the parameters. Okay, now what we have to go, what I'm going to find out is, now we have to do hypothesis testing. Okay, hypothesis testing about the slope parameters. Okay, so individually and uh, jointly we can test the hypothesis. Okay, so in simple regression model in SLRM, there will be only one slope coefficient, so there will be only one coefficient. Okay, or one slope coefficient, one intercept. So individually we can check the hypothesis. Okay, using t-test. Okay, whereas in the case of MLRM, there will be more than one slope coefficients. So you can check whether all the coefficients are significant jointly using F-test. Okay. Okay. So in SLRM, in simple regression model, t-test and F-test will be give you the same answer. Okay. Yes. So we have to go for testing the individual uh, test or individual significance of the each slope coefficients. So for that, what we have to do, we have to first we have to create h0 and h1. What is h0? H0 means that this y and x are not related. When we will get such kind of a things, when our beta 1 is equal to 0. Okay, so we assume that beta 1 is equal to 0, it's our null hypothesis. Okay, so alternatively you can hypothesis beta 1 not is equal to 0 or beta 1 less than or equal to 0, more than or equal to 0. Okay, depends upon your theoretical frameworks or your introspection. Okay, yes, beta 1 is equal to 0 and beta 1 is for time being I'm just giving beta 1 not equal to 0. Okay, so if I'm just giving equal to not equal to, then it will be a two-tailed test. Two-tailed test. Okay, so two-tailed test can be determined by just looking at the symbol in the alternative hypothesis. So in alternative hypothesis, it is not equal to sign, so our test will be two-tailed test. Okay, yes. So how we can find out the t value? Okay, for this value, we have got beta 0 is equal to, yes, 17.5. Okay, then beta 1 is equal to 0.573, something like that. We can find out whether these two values are individually significant or not. How we can do that? Using t-test. Okay, so beta 0 or t beta 0 and t beta 1. Okay, so t beta 0 means that, how we can find out this question? It is nothing but your beta 1 value, sorry, beta 0 value divided by standard error of this beta 0. Okay, so it is 1.55. In beta 1, this is the value divided by 0.062 something, yes, 9.106104. Okay, so the values are 1.551894 and 9.106104 or 9.10 something like that. Okay, so it is nothing but t values are your slope value divided by standard error. Okay, t values are nothing but t value is equal to your slope value divided by standard error. Okay, so we have find out the value for t for both beta 0 and beta 1. Okay, now how we can check whether these t values are significant or not? For that we need to have table values. Okay, so t table value we need table value. Okay, so how we can find out t table values? Using equation, okay, using the t inverse. Okay, there's a 2 in t inverse and t inverse 2t. Okay, since we are following two tail test, our command will be t inverse 2t. Okay, then you have to give the probability. Okay, probability means what? I am assuming 0.05, that means I am 95%, I am assuming 95% confidence level, and my type 1 error will be only 5%. Okay, the degrees of freedom n minus 2 is equal to 8, 2.306. Okay, so what is the decision? Decision is, if t values are greater than table value, you reject the null hypothesis. Okay, so look at this one, actual value 1.55, table value is how much? Yes. Okay, table value is actual value is 1.55 and table value is 2.30. Okay, what you have to do, actual value, actual t value is not greater table value, so we have to accept the null hypothesis. Okay, so here in second case we have to reject the null hypothesis. Okay, but look at in regression model, simple regression model, our hypothesis is whether beta 1 is significant or not. Okay, because beta 1 only will give you whether there is a relation or not. Okay, so no need to look at these things, you only look at these t values of the beta 1. Okay, and always the intercept will never give you uh, a coefficient which is significance or which has a meaning. Okay, sometimes it may give some other things which will not have any meaningful any meaning. Okay, so here we can reject the null hypothesis. Okay, then we reject the null hypothesis. What does it mean? It means that there is, that means y and x are related. Y and x are related. Is it okay? Yes. So in that way we can find out the t values. Okay. Or alternative to this t value, we can also use confidence intervals. Confidence interval of beta 0 and confidence interval of beta 1. What is this confidence interval? It is nothing but we will get a lower limit and upper limit, or lower bound and upper bound. Okay, so if your actual t values lies in between these two limits, then you can reject the null hypothesis. Okay, yes, so how we can find out that one? Lower limit is equal to, okay, beta 0. Okay, beta 0 means this minus, okay, then standard error of beta 1, this is a standard of beta, sorry, beta 0, okay, into, okay, t values, the t which you have got 230 minus 8.519, yeah, okay. If you just do the same thing, but instead of, yeah, what you have to do is equal to, this is the beta 0 plus this is the standard error into, this is the t value, okay. So if your values lies in between minus 8.519 and 43.585, you can make a decision on the basis of these things, okay. Similarly, you can also find out the confidence interval of the second things, okay. How you can do this? Equal to your at beta 0, so yeah, beta 1, 0.573 minus then standard error of beta 1 into table value 0.428, then next will be beta 1 plus 0.629 into your t values 0.7182, okay. So if the values are in between these two, you can take a decisions, okay. Yes, then one more thing is there, one more test is there, or one more value which is very powerful in statistical hypothesis testing, called the p value. How we can find out the p value? It is very simple, okay. So p value is what? P value is nothing but the smallest level of significance at which we can reject the null hypothesis. So how we can find out it? T distribution, okay, t distribution, yes, your t values, okay. For first things beta 0, this is okay, t value, comma, degrees of freedom is n minus 2, okay, 8, comma, oh, you can do one thing, t distribution, two tailed, okay. So it is this is the one value, comma, 8, okay, 0.159, and the same thing for this is p value for beta 0, okay, so beta, yes, beta 0, and this is beta 1, this will be t distribution two tailed, okay. Then x is the 9 point something into, sorry, comma, 8, okay. So this is very close to 0, okay. If you just find out the value, it will be very close to 0. You format the cell for number, yes, okay. So what does it mean? In the first case, we can only reject the null hypothesis at 100 or 1 minus this one, only 84%, or only for 84% confidence you can reject the null hypothesis about beta 0. But here this is 1 minus 0, 1 minus 0, that means 1, okay. That means 100% you can reject, you are 100% sure that you can reject the null hypothesis, okay. So this is all thing about the simple linear regression model, okay. So this is how we can find out manually all the estimation procedure and the hypothesis and evaluation test of simple linear regression model. Okay, yes. Now in Excel, there is a command or there is a inbuilt software or inbuilt program for doing this regression. Okay, no need to do all these things with a single click. You will get all these informations. Okay, for good data analysis, there's a regression. The command is regression is there. You just click OK. Okay, then you select the Y range. Y range means your dependent variables. Okay, then you select your independent variables. Okay, then you click labels. Okay, then you just click OK. Look at all the things that we have found is given here. Okay, so r square is 0.912. R square is 0.912. Okay, you look at what we have got. Yes, 0.912. Okay, now standard error 11.43. What we have got? 11.43. Yes, 11.43. Okay, now observations 10. Okay, then this is nothing but uh, correlation. Okay, y correlation between y and x. Okay, that's not important for us. Now this is okay. This is 1847. This is nothing but regression sum square or estimated sum square or what we call ESS. Look at what we have got ESS. We have got ESS 10847. Here also 10847. Then this is residual sum square. This is RSS. Residual sum square 1046. There. Yeah, how much we have got? RSS. Yes, 1046. Then this is total sum square. This is T. Yes, yes, 11894. How much we have got? Y square, small y square. If you sum it, no, sorry. Yeah, 11894. Here also 11894. Okay. Yes. So this is the f value. Okay, that's not important for simple regression model. Okay, but when we discuss about this multiple regression model, we discuss what is this f and all. Okay, then look at coefficient 1.753 and so this is intercept, this is slope. Okay, so 1.573, 0.57. Look at what we have got. Yes. Okay. Yeah. Then look at standard error. What we have got 1129 and 0.629. Look at what we have got 1129 and 0.629. Okay. So in regression, they are reporting the standard error, not the variance. Now T stat 1.55, 9.106. What we are getting? Yeah, what's that? Yeah. Look at this value. What we are getting? Yeah, we are getting the same value. Okay. Then p value 0.59 and 1.7 e, that means 0. What's the p values? Yeah, 0.159 and 0.000. We are getting the same p value. Okay, then look at this value. This is also the minus 8.59 to 43.58. Okay, and 0.4289 to 0.718529. Okay, so from this what we can understand that okay, the intercept we cannot accept or we cannot reject, so we can even though the regression is good in terms of goodness of fit and various statistical test, We can only explain or we can only interpret the slope coefficient because only the slope coefficient is significant, okay, but the intercept coefficient is not significant. Okay, so this is the way how we can do the regression analysis manually using regression and also using the analysis tool pack, data analysis tool pack. I hope that you have enjoyed. Okay, so you can also do the same experiment using the same data, and you can see how it look like. Okay, so thanks for being watching this video.